For a common emitter transistor amplifier, the audio signal voltage across a collector resistance of 2 kilo ohms is 2 volts. Suppose the current amplification factor of the transistor is 100. What should be the value of RB in series with VBB supply of 2 volts if the DC base current has to be 10 times the signal current? So our setup looks like this, where we have a 2 volt voltage drop across a 2 kilo ohm resistor, and 2 volts is provided at this point here, and we need to calculate what RB value is. One thing to note here, that signal voltage, whenever we say signal, refers to an AC signal, and then we have a base current which carries the AC signal. So if we have the audio signal voltage is 2 volts, that would be Vs, and since it's a collector, that is the output, would be equal to the current, the signal current which is in the output, multiplied by the resistance. So we have the output signal current would be equal to 2 volts divided by 2 kilo ohms, or this is equal to 1 milliampere. Now since the current amplification factor is 100, we have output signal current divided by input signal current is equal to 100. Therefore, the input signal current is equal to 1 milliampere divided by 100, which is equal to 10 microamperes. Now the DC base current has to be 10 times the signal current, or IB, or let's call it IDC for the DC current, equal to 10 times the input signal current. So this would be equal to 100 microamperes. What should be the value of RB in series with VB if DC base current must be 100 microamperes? So we have a junction here at the base and the emitter, which is this junction, and this has a potential drop of 0.6 volts, which is a characteristic of the PN junction. Now we have total potential drop is 1.4 volts, and this must be equal to the current 100 microamperes into RB. Therefore, RB is equal to 14 kilo ohms, and hence option A is the answer.